Hi, my name is Jay and this is my Maker Portfolio. At a young age, I witnessed many news and stories about artificial intelligence, and since then, I've always wanted to learn more about AI. In grade 10, I was invited to the Math Mentorship program offered by the Departments of Mathematics at the University of Toronto. Each mentee was required to complete a math research project in this program, and interested in deep neural networks, I read 2 papers about Batch normalization, a process commonly used to improve network training efficiency. I hypothesized that if batch normalization functions by centering and scaling the data, then introducing new stat to the already centered and scaled data would hinder the training convergence. To test my hypothesis, I developed 3 linear neural networks, one network without batch normalization, one with typical batch normalization, and one with not only the standard batch normalization but also additional non-zero mean and non-unit variance noise to disturb the centering and scaling effect of normalizing. After testing, networks using batch normalization with and without adding noise showed similar training efficiency, with both networks outperforming the network without batch normalization. This result suggested that the usefulness of batch normalization was not attributed to centering and scaling, and after investigating further, I realized my observation also matched a report in an MIT paper entitled How Does Batch Normalization Help Optimization? To put machine learning to a more practical application, I volunteered for a human brain imaging research that studies the correlation between brain activity and the speech information rate in grade 11. However, one daunting challenge in the study is the need to label the onset timing of each Mandarin word from the recorded speech among hundreds of participants. A research assistant needed around 3 hours to label a 10-minute long speech recording. To tackle this challenge, I created a program that uses machine learning speech recognition models supported by the open source Vosk API to annotate the timing automatically. After tuning and revising multiple prototypes, my program can label speech in seconds with 5 millisecond accuracy. This will help the research project discover brain language areas and networks using data from hundreds of participants. In the future, I want to study quantum computing for its vast advantage in training complex neural networks in parallel. These research projects demonstrated my preparation for this career choice, and thank you for listening.